Hello, welcome to my channel. Today we have Leetcode 463 Island Perimeter. So you can see this is a description right here. So I assume you see it before seeing this video. So in summary, the idea of this question can be simplified in this form. So now this will be the input of this 2D matrix. So this is the grid. So we input the grid to see what the island perimeter is. So what is perimeter? So for example, you know what's the island? Island for you can see is one. This one is connected to this one, and this one have the 4 directional connecting to different ones right here. And this all one are connected directionally. So now this whole entire thing is an island. In this simple graph right here, representing the island right here. So the outside border is the perimeter. So how do we calculate total perimeter of this island? So in this question, this is a good way to practice DFS. We're going to use DFS in here. And also to come up with a logical guess of how this the pattern is. So you can see if this area, which is 0, that is not island. But now in here, if this is island, how many bar, and we call this yellow thing is called bar right now. How many bar in here? So this have 1, 2, 3, right? So the pattern of this solution is when you see island right here, so we need to calculate the perimeter. So if it's touching the borderline, which is out of bound, then we have 1 bar right here. So if left or right, I mean, if that area is empty on the side, so we have a bar. You know, here same thing, it's areas are empty, so it's have a bar right here. So we're standing right here looking at downside that have an island. So in that case, we don't have a bar. So for this particular island, we have 3 bars right here. Same thing happened to this, empty, out of bound, empty, so we have 3 bar. So in this one, up is not empty, it's not empty, it's not empty, it's not empty. So for this particular island, we have no bar. So you can follow this pattern to calculate how many bars for each individual island, I mean area, land. Then you can come up with total for the entire land right here. And then we just output the island perimeter for the solution. So now we can take a look at the code now. So we have in for the output, right, is equal to start with 0. Like what we need to do is loop through the whole entire matrix, starting with I equal to 0, I less than grid dot length, so I plus plus. So also we have a j for the column started with 0, j less than grid 0 dot length, j plus plus. So that's how they loop through the whole entire grid. So now we capture I and j, the location. So f grid I j, we only care about when it's 1. For example, in here is 0, so we don't have any parameter right here. So only when it's 1, it's when it's a land, then we can calculate the parameter, the bar right here. So when this particular island is equal to 1, then we do things. So we have 4 direction, right? So output, so we have a DFS to calculate how many bar for this particular island. We can introduce that one later. So the idea of it, so output is parameter with plus dfs. Actually, it's not, it's a helper function that put in the grid inj, or actually we will need for direction, which is I plus 1 j output helper I minus j minus 1 j. So this is up, going up and going down. Also output I have 11, right? Left will have I constant j minus 1 is left. Helper with, sorry for the typing, j is plus 1, which is right side. Oh my god. So now this is 4 direction. We have a helper function to calculate the parameter accumulated to the output. One is 1. So that's good. After this one, so we loop through all the entire length and accumulate it to the output and return the output eventually. So this is a public method, right? We have also have public method that calculate for that line how many parameter it is. So we have a helper function that taking the grid. Now grid right here also have the location I and j. Okay, cool. So now for example in here we have a length. So if we check if it's out of bound, then for sure if I less than 0 or j less than 0. So like upper bound, left bound is out, then for sure is, what do? We'll return 1. Because if it's out of bound, so here's need the bar, so return 1. So also I bigger or equal than grid dot length, which is the bottom out of bound, and R and J bigger or equal to grid 0 dot length, which is the column right here out of bound. So this 4 out of bound, 4 way out of bound, they will return a bar right here. So that is let me see, I think okay, also if you see the right side, it's not out of bound but is empty, which is 0, it's water. And also grid ij is equal to 0, then also give them a bar right here. So this is just 4-way checking. So other than that, now we can see they're checking the area. So at that time, return 0. If you're not out of bound, you're not seeing the water right here, that means you're seeing an island. If this have island in here, no bar need to be added, so return 0. So this is a helper function. Cool. And I think that's it for this question. Let's see if it's working. Another typo. My bad. A lot of typo. So that sounds good for this question and submit it. Cool. And this is it for this question. And I'm here to do more time complexity, right? Let's take a look at the time complexity for this one. So first, we look through the entire matrix for every individual space right here. We need to do up and down, left and right. The worst case will be having everything's island. So every space right here need to check up and down, left and right. So we'll look through the entire things that cost n, because this whole matrix is n element right here. For every element, we have 4 directions to check. So that is 4n for the time complexity. That's the worst case. That's time complexity. So space complexity will be, we don't have any extra space. We might have only this variable extra. So time complexity is n, O of n. Space will be O of 1, which is linear. Actually, I mean constant. That's it for this question. If you have any question, please comment below, and I'm looking forward for your feedback. So otherwise, and I will see you in the next video. Hope you like it. Bye.